So the first presentation is from Markus Fischer, who is ITRPV Steering Committee Chair at VDMA, the German Equipment Association. He will let us know the maturity update of the famous ITRPV roadmap. Markus, the floor is yours.
So yeah, hello. I will switch on my video and now share my screen. Okay. Thank you, Shravan, for this nice introduction. So I want to give here an update on the maturity report of the 13th edition of the ITRPV. You can download this report also from the ITRPV homepage. So yeah, here, first of all, quick status. So for the 13th edition, I mentioned this last time, 62 contributors contributed. And in this autumn update, we always comment on selected parameters about the maturity status in the industry. So that means is the technology is in mass production or can be introduced in mass production, will be industry ready, or if there is still some development required. So first of all, I want to give here an update on the learning curve. So this is the well-known learning curve of price and volume. So the 1 terawatt of shipped modules was passed in March. And let's see what is then the situation, the expected situation end of this year. So last year end we had 183 gigawatts shipped at the price of 0.24 US dollars per watt peak. Keep in mind this is 2021 US dollar, and this year. So the good news is that the prices dropped for the end customers. The good news for us, obviously it's a similar situation like in past years, and we expect 250 plus gigawatts. This would mean we are really on the right track. And so 600 gigawatt of production capacity is online. So this is what we see. And another good news is that for overseas customers, the shipment cost reduced significantly compared to middle of the year, beginning of the year. So now we are close to a level of 20. So I think is good situation in what sales. And so let's now see what are the findings for the maturity in the different parameters. So yesterday we had interesting session about the technology developments. First of all, we learned that now the larger formats M10 and G12 are dominating. So we see also special formats, but they have a low share, and the smaller formats will disappear. And M6 is still present due to the economic use of life of the existing tools. So from the maturity point of view, we looked especially on the wafer thickness. This was also discussed. And here we distinguish in the ITRPV between P-type and N-type. And for P-type, we see that the reduction here is ahead of the projections. So we see that 155 microns will be in production. And also good news is we heard a lot was discussed yesterday regarding TOPCon. Also here, the 145 microns are ready for production. This is illustrated by this gray scale here. Yeah, also for the M10 wafers. For M12, obviously, it's a little bit slower, but it is well on track. And as commented here in the ITRPV, so silicon is still the most cost-intensive part for the cell and for the module. So the consumption reduction is important, and so we see that the current used 2.2 grams per watt. so can be reduced, and we expect that here for the next years we can go down to 1.6 also for this gram per watt, also for this large wafers. So this is very important and good news. So then regarding the cell, so we discussed intensively about the different technologies, and now we see here, especially for this diffused PN junction, so the TOPCon concepts gain market share and are in mass production ready. You mentioned 20 gigawatt are online this year, and so this volume is increasing. And so what is also good news is that this cell concepts are all bifacial capable, and they can be used in mono and bifacial modules. So this is a clear trend. Heterojunction has a smaller part, but it's also very important for high efficiency solutions. And yeah, regarding all the parameters for the cell itself, the J0 values of bulk and front and rear are always important. And there we see for the PERC cell, so this is also well on track here. So it also a little bit ahead, so that the reduction of the bulk losses is on track. But nevertheless, P-type is behind N-type. And we see here for this N-type, the 15 femtoamps per square centimeter for J0 bulk N-type is in production. And so also for TOPCon, maybe it's a little bit ahead. So this is well on track. So the material is ready. So then for the process point of view, we discussed this the most expensive non-silicon material for the cell is the silver, and we need to reduce the silver. And there we see for the different cell concepts, the silver consumption here. If we calculate this with power values of the modules, so then we can here conclude that we have a certain consumption of tons per gigawatt. And there we can see here for this milligrams per watt for PERC, or for this is here these are the values for PERC, and these are the values for TOPCon. We are here with this corresponding consumption values. So, and assuming that we have 250 gigawatts of shipment, so this is corresponding for the PERC concept to about 3,000 tons for the TOPCon. So we have 20 gigawatts. So this is within this volume here, and it's mandatory to reduce the consumption in order to meet really the targets of the industry to ship terawatts. And this is very important to go economic, to use silver very economic and careful. So we see that we are on track in the industry, and also the comments here yesterday in the yesterday session are optimistic. So heterojunction still consumes more. TOPCon needs to reduce the consumption, and PERC is also on a track to reduce for the future. So, and we see what is the mean of introducing this. So most important is the reduction of finger widths at the cells, and there we see the disappearing of 9 and 10 bus bars on the cells, and more bus bars are introduced, 11 to 12, and more or less currently 16 bus bars, and the trend to bus bar less. So this is what the industry is realizing, and this is very important to implement this. So, and what is about the technology, especially for the printing. So, and here for economic production of the cells, it is very important to see tool throughputs and the tool readiness. And here we looked in the ITRPV about the throughputs of the M10 tools. And there we see here for printers, so they are ready for really high throughputs. And so the 7,000 wafers per hour are standard for dual lane printers. And this is also good news, so that we can go forward here also to 10,000. It was a number unbelievable some years ago. But screen printing currently is still assumed as a mainstream technology. Plating will appear, especially for this high efficiency concepts. This can be a good alternative to reduce silver. So, and for the other tools, we see here also that the throughputs are on track. So with the gray scaling, with the gray color marking. And here for the thermal processes, we are a little bit, have a little bit less throughput, but anyhow here also the chemistry tools, the wet chemical tools are leading the crowd here for the front end. And very impressive is what ALD for the layer deposition for this passivation layer delivers throughput. So this is here leading in this layer deposition tools. So with more than 10,000 or with 10,000 wafers per hour, this is exactly the right to produce our high efficiency cells cost economical and cost efficient. So this leads me now to the discussed cell efficiency. So in the ITRPV, we do not consider here the cell efficiencies of the record cells, but the average of production cells, so cell in mass production. And it's also important here to consider the measurement method. So there's always a lot of discussion, but anyhow, we see, and also it was reported that for the TOPCon cells, we see currently in 2022, the 24+%. So this is here even ahead of the predicted parameters. And the headroom, so we see for all single junction cells, they are approaching their practical limit. So, and we see here that tandem will open the headroom, but it's not yet ready for mass production. So we see here with the red and purple coding, color marking. So there is still some development needed. So that leads me here to the module. So to the module efficiencies. So there is a variety of module power classes around, especially with these new formats. And a very helpful parameter for evaluating the product is the module efficiency. And this we learned as well, that the module efficiency also in the hit list or in the top performer list. So this is listed of TaiyangNews. So we see that for heterojunction, so it is leading the crowd with 22%, and TOPCon here 21.8% is in 2022 the value, and there are also values possible up to 22%. So this is what we learned, and this is well on track, and there is a really fast learning here, and this will be introduced. So for the expected future in the next year, so the 24% as practical limit, so we will see if this can be realized. And for tandem cells, we see that they will be introduced with efficiencies of about 26%. So after 2025, so it's very exciting to see when will this happen and what technologies it will be realized. So regarding bifaciality, everything is on track. So this leads me here to a discussion that was also mentioned yesterday, so the different formats. So we found that fortunately for the M10 module and for the M10 wafer format, we now have a standard. This is a 1.134 meters in the width. And this is very important, so to have here a standard, especially for not only for power plants, but especially for rooftops with limited space at the roof. And nevertheless, this requires careful product selection for optimum yield. And it was commented yesterday, especially for the power plants, this larger modules, so with up to 3 square meters, will be beneficial for the LCOE. But standardization, maybe also for the larger formats, is very important. So, and with this discussion of the module dimension, so this leads me here to the module product performance. So we also hear that the warranties of up to 30 years are becoming standard now. What we in the ITRPV asked is about the maturity of the first year degradation and the continuous degradation. And this is what we see, that here the about 2% for the first year. So this is now mature and it can be purchased. And also the linear degradation is here on track. This is around 0.5 per year. So this is on track. The 1% first year degradation is not yet mature in the market, but the first products appear. So this will also be interesting to see if the market will move in this direction faster, because we have this high efficiency cell concepts with N-type, the possibility to reduce first year degradation impressively, and this will be the task for the next years. So this leads me now to the end of my presentation about the status, and I want to encourage our community, and I want to see, so now PV gets really the importance and the focus that is really necessary. So in the ITRPV, we compare different scenarios. So, and the most ambitious scenario is a 2050 scenario by Christian Breyer. So it considers broad electrification and will require here states possible installation of PV of about 60 terawatt in 2050. So, and here we have a corresponding installation and market track. And if we really reach the 250 gigawatt end of this year, so this is a good news, we are on track to support this required PV growth for our future. And also there was an announcement by the International Energy Association. They promised that they increased the PV deployment. Nevertheless, I think and we believe that the scenario is still not ambitious enough. And for 2030, so the EER predicts 650 gigawatt. So we think that it will be more than 1 terawatt. And with the production capacities, we are ready to meet this target. So let's see. And with the high efficiency cells, I think we can reach this target. And higher efficiency will mean also reducing the module prices for watt peak. Yeah. So and the findings are, so the PV learning continues. So I'm very impressed that the prices reduced this year, end of this year. So we will see what is the final outcome. So the PV industry can also handle difficult world economic situation. So this is what we proved. And several 100 gigawatt markets are ahead. And with the base technology, especially also with this high efficiency technologies, we can serve these markets. And for multi-terawatt markets, sure, some requirements are, some efforts are required. But we have to emphasize efficient use of all materials will be the key. And so the ITRPV will also give the guideline for this results and for the future of PV in the next editions. So thank you very much for your attention, and thank you for all contributors. You can download the maturity report at the homepage. Thank you very much, and then please let me know if you have some questions.
Thanks a lot, Markus, for this update. I have, there are actually several questions in the chat window. It would be great if you can stay back and answer these questions, but
Yeah,
I still want to
okay.
ask one or two questions from my end. So is there going to be a preferred cell technology platform for the perovskites in the tandem structure? So is it going to be a more preferred from heterojunction, or it's more preferred from TOPCon or IBC? You know, everyone claims to have, they're compatible, but is ITRPV is also evaluating? So can we see something? Actually, this is also from one of the attendees.
Yeah, very, very interesting question. So, and so the current questionnaire is out. So maybe we can really add this parameter as a request as well, as a late call. Yeah. So thank you very much for this question. So from what we saw also on what we learned from the yesterday discussion, so there are several possibilities. Yeah. And finally, every company has to choose their best solution. So, and yeah, the bottom cell is an enabler for the tandem. Yeah. So, but the technology that fits best to the second junction. So this will be successful, and I expect that it will be a variety of starting technology. So you mentioned yourself, heterojunction is possible. So a lot of publications are with heterojunction, but TOPCon is also possible, and also we see that the P-type concepts are possible for tandem. So we can exclude BSF, so this is for sure. But for the other technologies, so far I think, and we see that the race is open. So we will see. But it's a good hint. Maybe we can add this question for the ITRPV 14th edition. Thank you for asking.
Looking forward to it. Okay, thanks a lot for the presentation.
Yeah, I will look in the chat. Yeah, thank you.
Okay.